Thanks for being here, everyone. This is a panel discussion about student activities for learning statistical concepts. My name's Alan Rossman. I teach at Cal Poly in San Luis Obispo. I have just a few slides to introduce the session, and then we'll be hearing from 7 or 8 panelists today. So let me go to my second slide, which is to remind you that back in February, we had a series of workshops on every Friday, including March 1st, which led participants through activities that can be used with students to introduce them to statistical concepts. Jen McNally led an activity that introduced confidence intervals in the context of a study about malaria in Yemen. Beth Chance led an activity that introduces students to one proportion inference in the context of a study about dogs sniffing COVID. Jill Vanderstoep led an activity that introduces students to comparing two means in the context of dung beetle navigation. And then Selma Roy led an activity that introduces correlation and regression in the context of predicting heights based on foot lengths. And finally, Beth Chance led a second activity, this one an introduction to ideas of probability in the context of the famous Monty Hall problem. And today we're very glad to have several panelists who took one of those activities and implemented with their students. And today they'll be discussing how it went and what they learned from that experience. So I've listed the panelists in the order in which I'll be calling on them today. We have Will Best from Belmont University in Tennessee, Amy Ballard from Brashear Middle College Charter High School in South Carolina, Bernadette Mullins from Florida Polytechnic University, Grace Nasness from Seminole State College, also in Florida, Lisa Nundorfer from Napa Valley College in California, Sonia Stanley from Samford University in Alabama, Tricia Buchanan, I wanted to cite because she's another participant who implemented an activity. She's at Penn State, but she will not be able to be here because of some family health issues that have arisen. And our final panelist today will be Sophia Georgikaki from Tompkins Cortland Community College in New York State. Let me also show you the questions that we asked panelists to consider, and then each panelist will be responding specifically to one of these questions. The questions we posed to the panelists are these. First, how much did you modify the activity to make it accessible for your students? Second, what were the main characteristics of your context and how you implemented the lesson? Third, what topics had students learned prior to the activity? Fourth, how different was the activity from students' typical class experience? Fifth, how do you think students responded to the activity? And finally, what challenges did you encounter with implementing the activity? So as I ask each panelist to share their thoughts, I'll ask them to tell us again what university or school or college they teach at, tell us a little bit about your institution, and tell us a little bit about the course in which you implemented the activity. For instance, is it a general education course? Is it a course for business students, for psychology majors? Tell us a little bit about the course. And please do tell us which of the activities you implemented. And then finally proceed to answer the question that you volunteered to address. So first I'll ask Will to address our first question about modifying the activity. So let me stop sharing and ask Will to take it away.
Thanks, Alan. So I'm at Belmont University in Nashville, Tennessee. We describe ourselves as a mid-tier D1 university that's still liberal arts. So we've got about 8,000 undergrad, and everyone has to take some core curriculum while they're here. I jokingly say we're a D1 university, but we're a Pepsi school. We haven't quite made that Coke school jump yet, but hopefully in the future we can get there. And this class that I implemented this in is our elementary statistics for the sciences. And so these are science majors, specifically psych, neuroscience, biology, chemistry, physics, and then math, data science, computer science, all science majors just lumped into one class. I'm going to preface this with I did this in my 8 a.m. class to see if moving would help them participate a bit more. It was a rather difficult, sleepy 8 a.m. class. We've all been there. We all know what it's like. So I'm just going to put that little star right there that this was a more difficult class to connect with. But I think this helped because instead of just getting up and lecturing, and I have them do group work, of course, but this was a little bit different when you're physically implementing something like this, where I did the regression example where they were trying to measure the size of their feet at 8 o'clock in the morning. It was just a little bit different from the normal, oh, it's stats at 8 o'clock on a Monday, which was good. It broke things up and helps them think about these things in a slightly different way. The reason why I wanted to answer this question is just due to the format of the class. Regression is actually taught in the middle, unlike a traditional kind of at the end of a semester, or at least what I'm most familiar with. We teach this in the middle because they have a final project over regression. And so we need to introduce it early so they can find a data set and implement regression ideas on that data set themselves. And so I taught this right at the end of that chapter as kind of our last day review before we moved on to hypothesis testing. But as a result, they haven't seen hypothesis testing. So I had to alter this activity a little bit because it kind of walks through hypothesis testing. But I didn't alter it that much. It ended up working really, really well as kind of an intro to hypothesis testing because they got to see the simulation, haven't done any other sort of simulation stuff like that before. So they kind of got to think in a new idea. And then we got to talk through, well, how would you test this? What would a hypothesis be? What is a hypothesis? We simulated it a couple of times and immediately they got to see the connection of, well, p-value is really just a probability. It's not something a computer tells me. It's something that we simulated. And so I can understand what that was. And that really helped in the second half of the semester when when we covered hypothesis testing, just because they kind of already had a sense for it right at the tail end of the regression. And so I had to alternate a little bit. I absolutely love doing this as kind of my day in between regression and entering the final segment of the course of hypothesis testing. That's really all I did to alter it. It went really well, but instead of just going straight off the script of the hypothesis testing, it was more of a discussion, which went well.
Great, thanks very much. The next panelist I'll ask to chat is Amy. Amy is also going to address this first question about modifications that were needed to implement the activity.
Okay, so I teach at Brazier Middle College Charter High School. It's a mouthful, but it's a high school in the upstate of South Carolina. And our students have the opportunity to take classes. We're on a technical college campus, but this particular course, Prob and Stats CP, is the lowest level of fourth year math that we offer. So many of the students in my class have not typically been successful in math classes. They don't like it, that kind of thing. And so for them, it's the first time for them. For a lot of my students, they'll say it's the first time I actually like math, or we get to like use math and that kind of thing. So it makes it a lot of fun for me. I have in the past taught AP statistics, but it's been quite a while. And so this is the first time that I'm actually trying to do some stuff with inference with this level. And so I chose the Can Dogs Detect COVID? And we had like 2 days before spring break before we hit our next unit. And so I wanted to see how that would go with them. So I made several adjustments to the handout. First, because giving them a sheet of paper with a lot of words on it can be very overwhelming for many of my students. So I put it in a program called Pear Deck. Basically it's Google Slides. And then they can respond and I can see their responses immediately on my screen, and I can highlight particular responses, good or bad. The students don't know whose work I've just put up on the screen. They just see the response, but not a name. So that also enabled me to kind of walk them through it, and so that we all stayed on the same page together before we moved to the next part. Another adjustment I made was just like a visual adjustment, so that Micah, the dog, when they had the sweat samples, there were 4 sweat samples, one that had a positive COVID test. So just at the bottom of the slide, I had 4 little sweat droplets, one with a plus, the rest of them with minuses, so that they could visually understand that these were the 4 samples. One of those was positive, so that was that 25% chance, just to make that connection between the words and like the understanding of it. Something else that I had asked that we do was we changed the applet so that it was red and green, because for them, red and green is like, go, green, red, stop. So green was the correct response and red noted the wrong. And so just to make that a little bit more clear for them. So yeah, those are the adjustments I made.
Great, thank you very much. So our next panelist will be Bernadette, who will be addressing the second question on the list, which was, what were the main characteristics of your context and how you implemented the lesson? So please go ahead.
So as Alan said, I'm Bernadette Mullins. I'm at Florida Polytechnic University. We are a STEM-only school, so we only offer degrees with STEM majors. So this course was the Intro Stats course, which has no prerequisite, but every student at Poly does take calculus, just for context. And my majors were computer science, data science, and business analytics. I implemented the comparing two means module, which involved the dung beetles. So these dung beetles, these little beetles, they crawl on top of a dung ball and they roll it away so it can be their food source, get it away from everybody else. And the research question was, can they navigate by the stars? So the research design was to take 18 dung beetles and randomly assign them to two groups, one with a black cap so they could not see the stars, and one with a clear cap so that they could see the stars, and measure the mean rolling time to safely squirrel away their pile of dung, their ball of dung. So I implemented this very much the way that Jill did when she did that with the faculty. So I feel like anyone who wants to do this can watch that recording and go do this in your class. Like, I feel like that was possible. And I used the resource, the PowerPoint, the handout, and then of course, been part of that recording. So I did it very much like she did, sort of an interactive lecture approach. So like at every stage, I'm stopping to ask students, like they're driving the content forward. So I'm asking them, what is our research question? What is the null, right? So very much waiting for that input to move forward. But then I guess I just wanted to highlight two parts of this that I think were most powerful. So our data that we have for these 18 beetles, the PowerPoint has these 18 index cards. Each card has a time written on it. Okay. And so it's first shown our two samples that show for the 9 with the beetles with the black caps, the 9 beetles with the clear caps, it's showing those cards with those times and then computing the mean rolling time to roll that dung ball away. So, and then computing the difference in those means. And then simulating the null. If there's really no difference in the mean rolling times between whether you have a black cap or a clear cap, if the stars don't matter, then we can just shuffle those cards around and it shouldn't matter, and we can recompute the mean rolling time. And so the PowerPoint, I think, was really powerful, that has this little animation that shows those cards physically being shuffled in front of you, putting them into two groups and recomputing the mean rolling times, and then taking that one reshuffling and putting one dot on the dot plot so students can see, okay, that is one dot. Now let's do it again. And then reshuffling it again and putting another dot, and then shuffling again and putting another dot. I think maybe the most important thing is not to do that too quickly. So students are like, taking your time to say, oh, if the null's true and we just redo that one time and then the next time and then the next time, that I think taking the time to build up, right, that simulation of the sampling distribution is so important. So then I did have my students go to the app. Now my students had, I'll say that my students, they've been working in groups since day one. So they are used to being working in groups every single day. So that's not an impediment. And then we had used the app before with the Reese's Pieces. So I think that familiarity made this go especially well. So maybe, the first time, maybe it takes a little more time to get used to the app. But, and so then having the students say, okay, go do your reshuffle, right? And then, bringing the app up. So I had been in the PowerPoint, bringing the app up, and again, just building up that sampling distribution, taking the time with one, then another one, then another one, then 10. Okay, 10 more, then 100, and then 1,000, right? So now we've got our distribution. And then to really ask that question, if the null really is true, how likely is it we got a sample like the one we got, or something more extreme? And I think just being able to see that, I think it was pretty powerful in terms of like conceptual understanding for my students of saying, what are we really doing here? I felt like it was powerful. And I also think like the materials are really well done. So if you want to do this, you can do this. Just go watch the recording, get all those materials, go do it in your class. I think you can do it. So I think it went well.
Great, thank you very much. Our next panelist will be Grace. Grace will be addressing the third question on our list, which was what topics had students learned prior to the activity? So please go ahead, Grace.
Hi, again, my name is Grace Nasnas. I teach at Seminole State College of Florida. A little bit about my college. We have about 23,000 students spread over 4 campuses and online. We're recognized to be one of the lowest tuition rate in the country for the last 13 years. In addition to AA and AS degrees, we offer 11 bachelor degrees in science and applied sciences. Our students have direct transfer to University of Central Florida. The STAT course I teach is a Gen Ed course and does not have any prerequisites. We mainly have students as first-year college. We have few dual enrolled students, and we have transient and a few non-traditional students. We offer 24 sections of elementary statistics STA 2023 about every semester, except summer we have a few less. I chose to work with the dump beetles, and which is comparing 2 means to test whether they use the stars to navigate, the same one as Bernadette used. This activity was introduced in week 14 of the semester, and I ran it with 2 sections, face-to-face classes with about 60 students total. Students have already completed hypothesis testing using 1 sample proportion, 1 sample mean, and 2 sample proportion. They already know how to identify the claim, set up the hypotheses, run the 5 steps hypothesis test using p-value method and using confidence interval method for 2 sample proportion. Students also know how to make a decision about the null and how to decide whether there is enough evidence to support or not support the claim. My students already have used the applets before earlier in the semester, about week 9, when we introduced the sampling distribution, and we use the applets to show how the sampling distribution approach a normal distribution with the central limit theorem. They have not done a manual randomization using the shuffle cards. Now, the fact I was a little skeptical to do this activity in one session, which is 75 minutes in the class, I divided it into 2 portions. The take-home portion was done prior to class, and it was online through Canvas, and where I explained the learning goals, the scenario, the experiment, the result, and I asked them questions prior on previous lessons that they already know. So I asked them all the questions that they know about observational versus experimental study, types of data, how to also how to form a hypothesis test, how to find summary statistics of sample data, how to draw box plot, how to draw inferences from box plot. All this they know before. What I added to the take-home portion is the manual randomization, where I actually made them make cards, put the numbers on the cards, shuffle the cards, and find the difference of the 2 means when they randomly selected, divided it into 2 groups. And then when they came into class, they know how to do a dot plot. So we got all these numbers that they obtained from the manual randomization at home. They put it on a dot plot, and that's what I picked up with the new knowledge of doing the applets for the p-value method, how to do the p-value using the applets in the classroom. Using, of course, I used the PowerPoints to, to gather all the information they did, and we picked up with the technology, with the applets.
Thank you very much. Next up will be Lisa. Lisa will be addressing the 4th question on our list, which was how different was the activity from students' typical class experience?
Hi, everyone. I'm Lisa Neusdorfer, and I'm from Napa Valley College. So we're in California, and I can sometimes see a hot air balloon during my commute to work. And we do have a vineyard too. I did the dog sniffing COVID test, just like Amy did. So Amy and I basically, there's a lot of similarities because I did it right before spring break also. So Napa Valley College is a small community college because of some legislative changes in California recently. We are really focusing more on statistics, creating 2 pathways, one statistics and one calculus. So this is why I'm sitting here today. So I do thank California for the opportunity to teach statistics, but I'll have to say that that wasn't my first choice. But but this, anyway, I won't go farther into that little pathway. But so therefore we have a lot more statistics sections because previously students had prerequisites to get in statistics, but now it's basically our entry level and transfer level class for students. So, and starting in fall, students will have the choice to go into calculus or go into statistics. So, for my class, it's almost identical to Grace. I have 2 sections, 75 minutes, 30 students per section. So that is pretty much the makeup of the class is kind of really mixed. I mean, at community college level, even though ideally they know what they're going to do, it's kind of all over the map. I mean, a lot of them are being funneled through statistics. Like if they're like, oh, I don't want to do calculus, they just are in statistics. So a lot of students don't know what they want to do, but we do have some pre-nursing and we have some psychology majors. I would say those are like the 2 that are, and that's some business because business also has to take statistics. But the nursing program, their previous math class, it won't exist anymore. So statistics will be their class. So I think, so when we decided Napa Valley College a few years ago to do statistics, there was a cohort, community practice that decided to go with the GAZE recommendations. And through that, we've been using Open Learning Initiative textbook and then also StatCrunch. So the statistical software, students do not do many hand calculations. It's all through statistical software. So that is the arena that I entered in. I know that there are different arenas out there in statistics, but that's kind of what I came into. So I did the dog sniffing COVID, and my question is what was different? Well, I would say, so I've been pretty much, I meet two times a week. And so I've been doing kind of lecture notes that correlate with Open Learning Initiative. And then I've been doing an activity Tuesday, Thursday, essentially. But a lot of the activities, since I'm new to statistics, I've been picking up a lot of activities from Stats Medic. So I noticed immediately like the difference in like the question, the levels of the questions and how well they were written. And it was, it was a pleasure, obviously, to go from Stats Medic to such a well-written activity. So I look forward to over the summer exploring. I mean, Bernadette was like totally selling us on the dung beetle. So you can do it. So I think I can see adopting other activities now that I've done this. So that was one different thing for me. We don't use the term observational unit in OLI. And so since I've been basic, I was like, that was different trying to explain it and understand it. Anyway, and the other thing was the prep for this for me was, it was long. It was a lot longer for me because I felt like I really needed to be prepared for the questions that the students asked, so the Stats Medic activities are a lot more, I don't even know how to describe it, but they're just a little bit more scripted and, kind of a little more surfacey. So I can answer most of those questions. So I had to be aware of the questions. I remember like the day before I was doing this, I'm like emailing Beth. She emails me right back, which I really appreciate. Like, what is the variable? Anyway, and then it's interesting to do it in class and have the same exact question that I have reflected back to me. It was a wonderful experience. I just want to pause for a second. Gratitude for you guys doing all this work. The collaborative was the same, so that was really helpful. And then the last thing is we hadn't used the Rossman Chance applet before. We've been only using StatCrunch. And so I went back and forth, StatCrunch, Rossman, back and forth. And then Beth was also helping me in our group. We were talking about it. And I just tried both and I just really liked the applet better. And so I created a activity before. So it was supposed to be a warm up like the day before about the Rossman Chats applet, but then it turned into an activity. And then Beth also like reviewed it, which was really helpful because it kind of made it stronger. And then, but the students took right to it. Like to me, it's so visual. Like it wasn't like this big thing, like, oh my gosh, I'm not using StatCrunch. They were very versatile with it. So then that wasn't a problem when we did the actual activity. So yeah, those were the main differences. And then the last thing I have to share was I was so excited. So with the 4 choices, I had them draw a picture. I love the sketching. I'm going to continue the sketching. I had this one student, very similar to what Amy was saying, but he sketched like a dog with like 4 petri dishes, and it was pretty amazing. But I got to use 4-sided dice, so that was really fun to do the simulation before we did it on the applet.
Hey, thank you
That's
very
it.
much. Thank you. Next panelist I'll ask to speak is Sonia Stanley. I think Sonia is going to address this same question about what was different in the activity compared to students' typical class experience. So go ahead, Sonia.
Can you hear me?
Yes.
Okay, good. I'm just going to confess that I got a new laptop in my office yesterday and I checked out Zoom, but I check out my camera. So I'm here, but you can't see me. So sorry about that.
No, thanks for being here.
Okay. And my laptop was pre-COVID, so I'm grateful to have a new laptop. So I am at Samford University in Birmingham, Alabama, which is a liberal arts university with numerous professional schools like a law school and a divinity school, school of education, and others, and with about 5,300 students total. I used my activity, which was the dog smelling COVID, in my contemporary mathematics class, because I teach statistics usually once a year in May term. However, I have just learned that I will be teaching it this fall. So I'm very excited about that. So since I wasn't teaching statistics this semester, I used it in my contemporary math class because we do have a statistics component. So it is different from what we usually do because I usually have a typical unit where we cover descriptive statistics, and then we also have a unit on counting and probability, theoretical probability mostly. And we do some group work, but it's typically practice where I will go over the ideas, work some examples, and then give them some work to do to check in on ideas before they do their homework themselves. So I don't do a lot of exploratory work in this class. We have a lot of liberal arts majors, no STEM majors in this class. So that's how it's different from what I usually do. I did modify the lab also in that we did not spend much time on the whole idea of probability as long run I'm not having the right word come to my mind. I've been messing with my computer trying to get the camera to work. Whatever, not empirical probability, thinking about experiments versus theoretical. And so I started the unit with the Monty Hall problem so that we could talk about and the other way to think about probability. And that was good because it gave us a chance to work with the applet before we actually focused on the dog smelling COVID using the other applet where we use the spinners. And we did have spinners in class that we used. I bought some spinners because I decided I'm not going to use this lab once. I'm going to use it multiple times, and I'm going to use spinners multiple ways in my classes. So I bought some spinners that have transparent foundations, so I could use it with different whether it's 1/3, 1/4 versus 3/4, whatever. I can modify the base using these spinners. So I just went ahead and invested in them myself because I'm in hook, line, and sinker. So that's how it was different. We don't do a lot of exploring in this class. I think I will do a lot more after this for sure.
Thank you very much. And congratulations on your new laptop.
Oh,
So
thank you.
Our
Thank
final
you.
Our final panelist will be Sophia. Sophia will be addressing the last of the 6 questions that we posed to the panelists, which is, what challenges did you encounter with implementing the activity? So please go ahead, Sophia.
Hi, everybody. I teach at Tompkins Cortland Community College. We are in central New York. We are very rural. For this reason, we support a couple of counties and unofficially a third county that actually do not have a community college that represents them. We are very small. We are approximately 1,500 FTEs. And similarly to previous panelists, we also have now changed into a no developmental math model. So our students come in and they can choose a pathway, and statistics is a requirement for many different pathways. So my general education statistics class, which is also the only statistics class we have in our college, has students from multiple disciplines, and usually students who the majority of them are not in STEM, so they are not very good at math. They struggle, they have anxiety, so and it is a freshman class. It does come with a core requisite, so half of the classroom includes students that are attending the core requisite class, which is right before that. It happens right before the regular class with the same instructor, so they are with me before, and then the rest of the class joins afterwards. And it does run for 75 minutes twice a week, which was the estimated time for the activity. The activity I did was the confidence intervals for the malaria in Yemen. And my mentor was Jennifer, who was amazing and also met with me before I delivered the activity. We are almost towards the end of our semester, but I did this activity in week 7. And at that time, the students did not know anything. So we had done descriptive statistics, terminology, sampling, things like that. We had done in probability distributions, discrete and continuous, So that's all they knew. They had never done inference. They had never done anything else. And confidence intervals would be 2 chapters later. But I used the activity in a different way. So I used it kind of as a review for our midterm. So the first half of the activity, where it asks you all these nice questions about what kind of study is this, what is the symbol, is it a parameter, is it a statistic, what kind of variable, all of these things are things that they need to know for their midterm that they would take like the next week. So I used that part of the activity just to get them to discuss these things between themselves and refresh their memory. One challenge we did have was that, unfortunately, we had a snow day that day. So our college did not close, but schools did close. So my attendance was very low. I only had 9 students in the class that day. So I could only do 3 groups for the activity. Usually I would have 20 students. So it will be much nicer to have 6 groups, but I had only 3. The good thing about it, which I think it made it a lot of fun. So in our class, we do use apps. We don't use the Rossmann chains, but my students are very comfortable going up on the internet. They do come with a laptop or a device or their phone, and all of these apps run really well. So it was great for them to see a different kind of app. It was great for them to see a simulation of randomization and of an experiment, which they don't get to see. They do work sometimes in groups. So this was another different kind of activity, because now usually they work with a partner, but now they had to be with more people. They got to turn around and talk to people behind them, which I thought was really good for starting conversation. And I was able to identify some students who were very helpful to others who had a difficulty, reading or like connecting the concepts. I did not change the activity at all. I left it exactly as it was. It did require a lot of reading, so I just let students help each other and read. And I used the very big poster size Post-it notes so that students could actually come up and write, and we would get to keep the answers instead of erase them on the board. So what was very unusual is that in our class, we do only one other activity where the students get up to perform some task in statistics. But for this one, they actually had to get up to write the mean. And having only 9 students was good, because then everybody got to get up and write, instead of if I had way too many students, they wouldn't be able to identify the confidence interval. One thing that I really, really liked about this activity was that my students were like fresh out of, just basic introduction to statistics. They knew nothing. So the significance is mentioned many times and defined clearly. The confidence is also mentioned many times and defined clearly. We did have an experiment where our original hypothesis didn't fall through. So they were able to understand that when you are making an assumption and it doesn't work, can you do a good educated guess? So they performed the activity to guess a different population proportion. So it helped them a lot. And then what has happened is, when we started doing inferential statistics, the malaria in Yemen example has come up at least once a week, right? So we are doing the sampling distributions. Oh, do you remember the malaria in Yemen example? We do the confidence intervals. Do you remember the malaria in Yemen? We do hypothesis test. What happens if you reject a null hypothesis? Do you remember the malaria example? So it's always coming back as, do you remember the activity we did, and how would you do it in real life? How would it apply to this particular topic? So I think that overall it was a great activity for my students. It always gives me a very concrete example to reference. And we were also doing it during Pi Week. So we had our marketing team taking photographs of our class as we were working. So we have very nice photographs published on our social media for my college with our students during that particular activity that week. So thank you, Jennifer.
Great, thanks very much. Thanks to all the panelists, not only for implementing the activities, but for taking the time here to share your insights with us. Before I throw it open for anyone to ask a question, you may have noticed there was one of the 6 questions that I posed at the beginning that we did not have a panelist specifically address, because the panelist who was going to address that question couldn't be here. The question was, how do you think students responded to the activity? And some of the panelists addressed that to some extent, but if any of the other panelists want to say anything about that question before I open it up to everybody, how do you think students responded to the activity? Anyone want to respond specifically to that before I ask for other questions?
At 8 o'clock in the morning, begrudgingly so at the beginning, but with more enthusiasm by the end.
Great. We actually have 7 a.m. classes here at Cal Poly. I taught one of those in winter quarter. So I sympathize with 8 a.m., but I can do you 1 hour better.
Yeah,
Any other questions?
I taught it twice to an 8 a.m. class and a 9:15 class. And to my surprise, my 8 a.m. class was really into it. They really enjoyed it more than my 9:15 class for some reason. They were really into it. They really appreciated the hands-on part of it, I think. And just the fact that it was very active. They enjoyed the active part. And they enjoyed the, I guess, the current events part of it. You know, just the fact that it was more than flipping coins and taking marbles out of a bowl, and it was something they could relate to. So they really enjoyed it.
Great, thank you.
I can say that my students, they really enjoyed the idea of talking about an experiment, the real experiment that researchers actually do, so they can apply statistics in the future. Like, this is how we can apply statistics to a research. They were a little bit lost with the wordings, even though I tried to change. Jill did a fabulous job with the worksheet. It was beautiful. The PowerPoint was amazing. I had to change a little bit of the wording just to use what we commonly use in our book. But they felt that it was, the content was, they were asking a lot of deep questions in the thinking. They needed a little bit of guidance of, this is what they mean in this question. It was maybe the first time they were able to see where, when we showed the arrow of the p-value being so far from the rest of the histogram, that was like, oh, now we know what that means. They understood what does the p-value mean, and that was my take out of it. I'm like, I hope you understand what it means, and after doing the experiment and the picture. It took time, like even though I cut the experiment into 2 parts, the half was done online, one was done in a classroom, but I wanted to give them the time to read and answer, and I was walking around, and it took time. Like, I don't think I can cover this again in just 1 session. It has to be split in 2.
Thank you.
And I'll just echo what other people have said. I think the students responded well for what people have said, that the kind of a real world context with a real research question is interesting, the sort of hands-on engaging aspect, and then the focus on real conceptual understanding, like really seeing what's going on. I think those were 3 positive aspects for my students.
Thanks.
I like the progression. We do a lot of hands-on, of course, with a high school class, but the progression from the spinner to then the online simulation to then like the abstract idea of it. So it was nice to have that physical spinner for them to do first before we moved on.
Thanks. Any other quick reactions before I open it up to more general questions?
I wanted to say about the malaria in Yemen, since no other panelists did that. So what I liked about the activity is that it actually gives it in context, like why would you care if there is malaria in Yemen? So it puts it in context, and basically it says that we are testing patients who have fever, and we want to pretty much guess if they may have malaria or not, and your job is to order medication for this particular hospital that you are working for, and you need to kind of predict how much medication you are going to need. And then based on that, the activity concludes at the end, what happens if you overorder, or how would you consider the possibility of overordering? You will need to know the expiration date of the drug, like take other variables into account. So it starts also giving them some idea of multivariable thinking. What other things should you consider except for fever? So I think it puts it in context, and it just makes it realistic, which and it makes students understand that you could be doing a statistical investigation that doesn't seem related to something specific, but it actually pertains to a specific job that you have to do, or an analysis that your client needs from you, which I thought is great to put it in context.
Thank you. Okay, let me invite anyone to ask a question of the panelists. Feel free to unmute and ask. If you prefer to type in the chat, you can do that. Any questions at all for any of the panelists?
I'll ask one, but actually it was just partly answered about the tactile simulation before the computer simulation. I was going to contrast Bernadette and Grace, because Bernadette, you didn't mention a tactile simulation, and Grace, you told them to go do it at home. And I was wondering if they actually did it, and whether you felt that was a important step in either case.
Yes, they actually, well, I did it first, when I created my canvas, I showed them exactly how to do it. I showed them the card. I talked about it before they went home and did it. And the second day was so cute. They actually brought the cards, and they said, so do you need to collect those? But I really wanted them to see what does it mean to have, what does simulation mean? Like if I want to only show them the applet, they wouldn't know what it means, a random sample, by simply picking like those numbers and do it. So so they put the numbers on the dot plot, even though with 30 students, maybe I had like 25 who came into class. The 25 wasn't enough to show how this is going to be all centered. And then I went through the PowerPoint, and in PowerPoint, that beautiful animation that we all asked Jill to give us the command how to do the animations of the shuffling card was fantastic. They all had their lives. Wow, this is fabulous. They thought I did it. I didn't take credit for it, but it was beautiful. So, and then we applied the statistic, the technology, the applets on top of it. So they got the whole picture of starting small, then get to 1,000 sample at once.
And I'll just mention that I do see the value and usefulness of actual tactile simulations before app simulations in general. Just with the 9 cards and the shuffling that, and then computing the mean. I have a 50-minute class, and I just didn't think physically doing that was going to be possible within my time frame. So I didn't do that. I did have students, each of the students was using the app themselves, so they could, do a simulation on the app, but I didn't have them do a tactile one. But I'll mention in the past, not in this class, but in the past, I have done, for example, groups of 2 students flipping 16 coins, for a different simulation. And so, I do think that actual tactile simulation was cool, and it has power. It's just that in this particular case, just with the 18 index cards shuffling and computing an average, I just didn't think it would, it would work in 50 minutes, but that doesn't mean that I don't get that tactile simulation has power to help students own that and understand that.
Thank you.
Thank you. Ben has raised his hand. Go ahead, Ben.
I wanted to ask the panelists, when it comes to be May each year, I already start thinking about next year and what am I going to change for next year? And after the two panel talks, one of the things I'm thinking about is the power of simulation to let me drop some topics in the stat class so that I have more time. I'm wondering if others are thinking that way, because it seems like simulation itself is such a powerful way of thinking. It lets you deal with a variety of different situations that could come up that need statistical and inferential thinking, that I don't have to race through every single theoretical formula in the class. If I can cover a few in a better, more thorough way, students leave with something more valuable. Are others thinking along this path and thinking about what they might drop?
Well, one thing that I was thinking, and I think this is something along with what Sophia said, is she keeps referring back to the activity that she did. And so when I did the activity, it set me up actually, and I didn't realize it at the time, but it really set me up for later activities. So I think that they're very rich and a lot of them can be extended, like the COVID dog could be extended to hypothesis testing. So I have been thinking the same thing, Ben. I've been thinking like kind of laying it out and looking and for me it's very easy because we have like our curriculum as it is kind of in assimilation and more conceptual anyway, so I could do more. But you just have to also do more planning because we actually are going to a 16-week schedule. So I will be in a 50-minute class too, and I'm going to miss from 75 to 50. So you're going to have to do what I've been thinking about is maybe making kind of like what Beth was modeling, like some more Canvas quizzes to kind of like prep them for the class. I know some students won't do it, but just kind of to try to make the timing work is to have some more of that like front loading, I guess. But it doesn't make me feel like I'm missing that material. But then it also, I guess, Ben, like just talking out loud right now, it also changes your assessment. So it's kind of like, it feels like that is something also that you need to consider, or I'll need to consider. Like what will my assessment look like if I'm moving to more simulations? And it was really nice. I don't know if this was in all activities, but in the COVID dog activity, the very end were sample assessment questions. And I think that like is another layer that has to also be considered because assessment should match what you're doing in class. Actually, in some ways, it'd be great if you start with assessment if possible.
Thank you. Other reactions to Ben's question about topics you might drop and emphasize simulation and the general principles?
I'll echo that there's topics I can now include that I didn't used to, like inference or median or relative risk, because it does give you a framework that you can do with all kinds of things.
Other reactions to Ben before I ask for a new question? About a new question, anybody?
I wanted to hear more about the paired deck that Amy was using. I haven't heard of that before. That sounded kind of cool. It almost sounds like what you can do in Desmos.
Yeah, so it's similar to Desmos, but you just build a Google slide presentation. And then you add Pear Deck is like it's its own website, but then you do an add-on to Google Slides, and then you can set up each slide to be like complete, yeah, somebody just pasted the URL, yeah. But you can add like text questions. They just have to type in their answer. You can do multiple choice. You can do number answers, which the number ones are cool depending on what it is, because it'll make like a graph of what their numbers are. So you can see the spread and that kind of thing, which is cool, depending on what you're doing. Desmos is definitely more geared toward math, but it just depends on what my purposes are. So I like it.
Thank you. Another question? It's about 3 minutes till the top of the hour, so we should wrap up soon, but about another question.
Yeah, I mean, I think you've probably addressed this in different ways, but for someone who's never done any of these activities before, or would like to introduce something like that, what would your one piece of advice be for a beginner?
So, I was a beginner. I have not done something like this before, but now that I'm thinking of what the other panelists did, I am starting to think of, there are some ways for us to actually embed a bunch of this ahead of time. For example, if I were to do the dung beetles, I would, in my first chapter, we are doing sampling and then observational studies and things like that. And then our second chapter is descriptive statistics. Instead of giving them a project, the current project that we give them to do the descriptive statistics is like the rain precipitation in Syracuse, New York. But instead, I could just give them the two dung beetles, the cards, right? And then ask them, find the mean for this and this for that, graph them, do a shuffle, like they can use some kind of randomizer to shuffle the cards, redo this 3-4 times. They will practice, calculating the means, and then eventually we can go back towards the end of the course and say, do you remember that project? Let's pull it back up. If you have data from all of the students who have done the simulation for you, then showing them the app will be much easier. So I am thinking that if you go through some activity, you can figure out some ways to incorporate, a bunch of stuff early on, so that when you actually are in class, you can bring up the activity and it's going to already be done by your students ahead of time.
I can add to this real quick. I know we might be short in time, but I can add something small. I introduced the two means after I already talked about the hypothesis testing with one sample and two sample proportion. They already know how to find the p-value, and they just go on StatCrunch, do the math, they just finish. So, and then they understood what does the p-value mean. I wish I did it early on when I first started the hypothesis testing, for them to understand what's the p-value. So, because then, they were like, oh, I mean, I should have, mentioned this before. Well, yeah, that was my intake. Maybe I'll pick something that I usually introduce a chapter with a scenario. And that p-value has to be introduced in the beginning for them to understand what it means, before, they get the number and they do the math that they need to do.
Thank you. Other reactions? Quick advice for beginners? I've been typing, I'm not good at multitasking, but I've been trying to type a few things into the chat to point out there's an electronic conference on teaching statistics, ISI-Stats, happening in June of this year. And 2 sub-teams from our team will be presenting there. Jen will be presenting a breakout session on June 12th. And Soma and Beth will be presenting a workshop on June 18th. But ISI-Stats has lots of great sessions, keynote talks, breakout sessions, poster sessions, workshops, reading groups, lots of interesting things going on. The registration fee is only $25, and there are discounts available for 2-year college teachers, high school teachers, and some others as well. And I put the link in the chat. You can also just Google electronic conference on teaching statistics and learn all about it. We also planned the group that's been doing these virtual workshops. We plan to have a virtual workshop in late July on the topic of multivariable thinking, but we have not decided on the date or dates for that yet. But I'll be sending out emails to advertise that in a week or two once we decide on the dates. And we will continue to have workshops next year, virtually, and some in-person workshops as well. Any other questions? We're past the top of the hour, but if you can stick around, I can stick around, and I assume some others can too. So maybe I'll stop the recording now, but if you want to stick around and ask more questions or chat, feel free. But I do want to thank everyone for coming, panelists especially, but everyone who's come to participate.
Thank you so much.